Okay, so now we're going to have a look at question 4 on the document. And the reason we're going to have a look at this is because we're not given the velocity of one of the objects in terms of I and J. So we're going to have to do a little bit of work to get that. So it says ship P is 3.4 kilometres due west of ship Q. Ship P is moving with speed 5√2 in a northeast direction. Okay, northeast means, of course, that's going to be 45 degrees. And it's moving with a speed of 5√2. And also, that's meters per second. And it says that Q can travel at 13 meters per second. So we don't know the direction of Q. All we know about Q is that its speed is 13 meters per second. And because these are in obviously meters per second, then I have to change the units for the original displacement. So instead of saying it's 3.4 kilometres due west, I'm going to say it's 3,400 metres due west, and then I'll have my unit match. Okay, so these two ships are on a collision course. Find the velocity of Q. So we're going to assume that Q is going to head up in that direction. Okay. So we want to find the velocity of Q. So that in terms of I and J, when will the collision happen? And we don't need position in this particular question for the position of the collision. But anyway, let's begin. If they're on a collision course, then of course the slope of the VPQ must be equal to the slope of the RPQ. So let's get all my bits and pieces, all the bits of information. What's the velocity of P? I'm going to draw a triangle around that P vector there. That's a right angled triangle. This will be the I component, that will be the J component. 5√2 is the hypotenuse. So the VP is going to become 5√2 cos 45 on the I plus 5√2 sine 45 on the J. So they're both moving positive direction. Cos of 45 is 1 over √2. Sine of 45 is also 1 over √2, which means that the VP becomes 5i plus 5j. Okay, that's the first piece of information. Right, what's the velocity of Q? Now this I don't know. No idea what it is. So I'm just going to say it's AI plus BJ. And my job then will be to find A and B. I do know one thing though. I know the speed of Q. And to get the speed of a vector, remember if this is my velocity, to get the speed of that velocity, or to turn that velocity into a speed, it's the square root of a squared plus b squared. Okay, and I know that that's 13. So the square root of a squared plus b squared, if I square both sides, that will give me 169 is equal to a squared plus b squared. So that's a nice little equation. I'll be using that now shortly, so I'm going to leave that there. Pay attention to that. Okay, so the other bit of information I need now is the position of P. So what's the R of P? The position of P, of course, is along the I-axis minus 3400 on the I plus 0j. And the position of Q is at the origin. Okay, so now I have all my information. So let's find the RPQ. The RPQ will become minus 3400 in the I direction minus 0i. And of course 0j minus 0j will just be 0j. Now let's get the VPQ over here. So the VPQ of course will be VP minus VQ. And the VP is 5i plus 5j. And the VQ we've said is AI minus BJ, so I'm subtracting both of those. I change the signs. That will become 5 minus A. I'll gather the I bits and I'll gather the J bits. 5 minus B and the J's. Okay. So I have my two bits of information now, and I'm going to show now that the slopes of them, if they're on a collision course, the slopes have to be equal. So the slope of VPQ of course, will be the j's over the i's, which is 5 minus b over 5 minus a. The slope of this one will also be the j's over the i's, 0 over minus 3400, and I keep that minus when it's slope, because I'm not using north, south, east, west tag, so the sign's important. Okay, so if they're on a collision course, these have to be equal. So I'm going to put them equal to each other. 5 minus b over 5 minus a is equal to 0 over minus 3400. I will cross multiply here, and this will become 3400 multiplied by 5 will give me, I'm looking for my calculator, 3400 multiplied by 5 gives me 17,000. So this is minus 17,000 plus 3400b is equal to, when I bring that 5 minus a up, that just becomes 0. So I have 3400b is equal to 17,000, which means that b is equal to 17,000 over 3400, which goes in 5 times. Okay. So once I have b, I can then substitute back in to get a. So what do I know? What equation would be useful to me here? Look at this one. So 169 is equal to a squared plus b squared. I now have b. So 169 is equal to a squared plus 5 squared. When I bring that over, I get 144 is equal to a squared, which means that a must be equal to 12. Now, for these directional things, it's always handy to give yourself 2 options, just in case the question asks that. So I would say that a is plus or minus 12, because when I square plus 12, I get 144, and when I square minus 12, I also get 144. So sometimes if you're looking for 2 directions or 2 velocities, that's how you get yourselves out of that sort of trouble. Okay then, so my object of the exercise was to find the velocity of q. So the velocity of q is ai plus bj, and I can see if q is going to collide with p here, it's going to head off in that negative I direction. That would be its quickest route to interception, we'll say, or collision or whatever. So I'll go for that option. I'll say minus 12i plus 5j. That is one direction. Of course, it could also go in that positive direction and head up that way, which in that case would be 12i plus 5j. So it's either or, you know. The question says to me, when will the collision happen? So the time to the collision, of course, is relative distance, relative displacement over relative speed. So the relative displacement is the RPQ, which is minus 3400 on the I, plus 0j. I'll get the mod of that, and I'll divide it by the relative velocity mod, which in this case, of course, is 5 minus a on the I, plus 5 minus b. So I'll just go and find what that is now. So the VPQ is equal to 5 minus a will give me 5, if I take this version here, 5 minus minus 12 will become 17 in the I direction, plus the j direction will be 5 minus b, which of course is 5 minus 5 in the j direction. So this will be 17i plus 0j. And when I put that over here and get the modulus, how many times will that 17 go into that? If I square it and get the square root, that will go in 200 times. So it's 200 seconds to collision.